Welcome back. This is Innk, and this is a previous problem that we found the current through a capacitor. Link will be in the top right of this video. So we want to use the current found in this problem to find the expression for the charge on the capacitor. So since we can write that our current is defined as the rate of charge. So the rate of change of charge, we can write that as I is equal to the rate of change. And that is with perspective to time of charge, which is Q, that is measured in coulombs. Well, charge is measured in coulombs, not the current. So let's just erase that. So if we want to find the charge, we can manipulate our expression to find our charge. So therefore, we can say that in this case, let's take the integral of both sides. So we can integrate both sides. So we integrate I, and that would be dt. And if we integrate the right-hand side, that will equal to q. So we then can note that, well, let's just look at this problem to make it clear and obvious. So if you notice that V of t, the voltage, so the fundamental equation for the voltage across a capacitor is given by the following. And as you can see, we have part of that expression. So we can therefore go ahead and multiply both sides of our equation by 1 over c. So if we do that, we then get that 1 over c, bring back our integral, et. You could put plus k if you want, equal, and that will be q all over c. You'll then realize that, as we just mentioned, that this is the voltage underlined in blue across the capacitor. So that is the voltage across the capacitor. So we can write V, voltage across the capacitor, is equal to the charge on the capacitor divided by the capacitance. To find the charge, we then manipulate that. So then we get the expression as follow. And by doing this, we can then go ahead and say that, well, not say, we did get that. So our capacitance is 50 microfarad. So we can multiply our 50, oh, I can just say e to the negative 6 times our voltage, which we had 100 for a coefficient assigned 200 and t. So that is the charge, which is then equal to, so the expression of our charge, 50 times 100 is 5,000. And just bring the sign t, and that is the e to negative 6 is micro. So that would be microcoulomb. So that is how to find the charge. Well, find the expression for the charge on a capacitor. You can then go ahead and plug in at certain instances to see what the charge will be at that time, that specific time. So that's it for this problem. See you in the next one. Bye.